So a little bit more practice with linear regression, line of best fit using Desmos. We'll go through the first problem together, and then I think I'll let you guys try the second one on your own to see how you do. So for this first one, Tiffany is trying to save money for college. She's tracking the balance in her checking account after each month. In January, she had $770. In February, she had $815. In March, she had $901. In April, she had $890. In May, she had $997. June was $1,190. July was $1,433. Whew. Identify the independent and dependent variables and create a table of values. Then graph the data and label the X and Y axis. So the two units of measure that we're talking about here are the months, which will represent numerically, and the amount of money that she has saved. So independent is always time. How did we measure time? Time was measured in months. Each month that passed, she checked her checking account balance. And then our dependent was the amount of money she had saved. So January, month 1, she had $770. February, March, April, May, June, July. And yes, I don't have enough lines for all of this, so I just kind of squeezed it in to make room as best I could. From there, we're going to determine the equation for the linear regression. So I'll again open up Desmos here. I have stuff from a previous lesson, so I will have to go through and delete that so that I have a fresh, clean page. So I go plus, table, I'll type in my X values. It was just 1, 2, 3, 4, 5, 6, and 7. And then money saved, we'll type all those in. Okay, and then I should have the same number of X values and Y values. If not, go back. You probably skipped something. And since I can't see anything, I am going to zoom out. And this time, all of my points are kind of like right on top of each other. Well, that's not very helpful. Okay, so what are we going to do? I'm going to hit this toolbar, this like wrench symbol that's in the very upper right-hand corner of my screen. I'm going to hit that. And I'm going to change my X-axis to fit my X values. So I'm going to go, my X values go from 1 to 7. I'm going to make it easy and go 0 to 10. Okay. And then for my Y axis, I'm looking at the Y values from 770 to 1431. Let's go 500 to 2000. You just need to pick a number that's lower than the smallest number and higher than the biggest number. And then we'll just click out of there. And now I can see all of my points. They're not all right on top of each other. They're not all aligned vertically. That wasn't very helpful. I couldn't really tell anything from my data. And then from there, I need to determine that linear regression line. No, it's not essential for you to see the points, but I just wanted to show you just in case you wanted a visual representation of the money. So we're going to type in Y1 squiggle MX1 plus B. And I'm going through this fast because hopefully you've already caught on how to do it. If not, just keep rewinding the video until you've caught up or pause the video. Okay, so we have our M, which is our slope, and our B, which is our y-intercept, and I will plug those into my equation to make a line of best fit. And it's y equals 101.25x plus $594.43. And then I graphed all that. I'm not going to waste too much time on a video making my graph and plotting all of the points, but I have time on my x-axis, and I went 0 to 15, and then I have money saved on my y-axis, and I went 0 to 1600. Again, as small, like smaller than the smallest to the highest. And remember that you're scaling your graph with equal intervals. Don't just graph the X and the Y of 750, and then your next line is going to be 815, and then your next line is going to be 901. It's not going to be very accurate. Now, when we're graphing the line of best fit, I want us to try and actually graph that line of best fit. So I graphed my y-intercept, which was 594.43. I just kind of eyeballed it right there. And then remember, a line is created by 2 points. So I wanted to find another point that was on this line and graph that point. So how did I do that? Well, I took my line and then I just chose an X value. I chose 4. You could have chosen 5, 6, 7, 8, 9, 10, whatever you want, and plugged it in for X. And then solve, and I got 999.43. Okay, perfect. So then I went to my graph, and I graphed the coordinate 4, 999.43. Obviously, I just kind of rounded to 1,000, but I went to 4, and then I went up 999, graphed it a little bit below 1,000, and then I connected those 2 points. So on your summative, if you want full points for graphing your linear equation line, this is what I would want to see. I want to see you graphing your y-intercept and finding another point that's on the line using your equation that you just found, graphing those 2 points, connecting them with a line. Okay, that was a lot. Whew. Okay, next one. Interpret the meaning of the equation in the context of the problem. Okay, so we need to interpret our slope and our y-intercept. Well, this slope is how much money she will have saved each month. And she started with a predicted $594.43. And this was her month 0. In January is this pink dot, this first pink dot here. January she had $770 after January, or in January. That's saying that in the previous month, maybe, or before she actually started counting, it was predicted that she already had $594 already in her account before she started saving. So either the previous month or just she didn't count it at that time. And then how close is the linear regression line to the points? I would say that the most of the points are pretty close to our line of best fit. Maybe this point is a little farther off from our line, but the points down here are all relatively close to our line of best fit. So I said most of the points are pretty close. And then we want to predict how much money Tiffany will have in March of the following year. So remember, a year is 12 months. So we went all year long. And then we're saying March of the following year. So we went full 12 months, and then January, February, March. So we went 3 additional months. So that means that our X value is going to be 15. 12 months in a year plus 3 more months. And I'm going to take that 15, and I'm going to plug it in to my equation, and I'm going to plug it in for X. So I just took my linear regression equation that I had, plugged 15 in for X, literally just typed it into my calculator to find that $2,113.15. And then, of course, I want you to explain that answer in the context of the problem. So it is predicted that she will have $2,113.15 in March. Again, this is a prediction, so I need the word predicted in my answer because it's not actual fact. It hasn't happened yet. So we can't say with absolute certainty what she's going to have. And then how close is your predicted value to the linear regression line? So we're going to look at our line, and we're going to see if that green line that we drew in is pretty close to 2,100. Okay. And it actually looks like our graph, if we extended this line, it's going to definitely like go off the chart. Okay. So, oh gosh, now I don't know. I don't have enough room on my graph, but remember, we used the line of best fit. We used this equation. We used the green lines equation to predict how much money Tiffany will have in 15 months, in the next March of the next year. So, hang on with me here. Our prediction is going to be on the linear regression line. Since I used it to make my prediction, I used the green line. Instead of looking at the green line visually, I used the actual equation to the green line to make this prediction. So it is going to be on my prediction line. Okay, hopefully that made sense to you. Go ahead and try this second problem. The answers will be on the answer key for you so that you can double check your work when you are finished.